Welcome everyone. In the next couple of videos, we're going to cover Chapter 3. I'd like to remind everyone, while this lecture will cover a lot of the topics, it's still not a substitute for reading the chapter. Make sure you read the chapter, and I definitely suggest doing the assignment before you do the quiz. In this chapter, we're going to talk about Boolean types. Boolean types and being able to compare these Boolean types is really important when it comes to programming. Without it, our code would simply be lines of code that would be executed from the very top all the way to the bottom without any way to manipulate flows of code. Essentially, your program would do the same thing over and over and over again. No way to deviate and change up the code as the user needs it to change. You wouldn't be able to ask the user any questions and then change your code based on those answers. So as you can see, the Boolean type is really important. In Java, we have 6 comparison operators, and these are known as relational operators. The result of these relational operators and the comparison of them turns out to be either true or false. Do you remember back when we were talking about machine code being zeros and ones? Well, that's where we get the true and false from. So let's talk about this. In this example, we're asking, is 1 greater than 2? And the answer is no. In fact, it's false. So false will be stored in this variable b. Now while we're on that, on this slide, they've referenced variable I, j, and b. I want to take a moment and say there's only one real time that you can use single letter variables and it be meaningful. And for the most part, that's in the for loop. Otherwise, using single letter variables would be, well, they just wouldn't be seen well in any organization you might work in. And just like that, it's not taken really well here in Java course. So when you're doing your homework, don't use single letter variables. Instead, use variables that have some meaning, some value. So that way, when other people are reading your code, they absolutely know what your variable means. So certain variable names that you may see, like CNT, that could be count. If you're doing a variable that you're checking on page numbers, then I would say you'd want your variable name to be something like that. So keep that in mind as we go forward. Now let's talk about relational operators. In this column, this is what we type when we're programming in Java. And this is what they relate to in math. Let's start with less than and greater than. These are known as exclusionary comparisons. And that's because whatever number it's being compared to is not part of the actual comparison. I know, you're probably like, Professor Waits, what the heck does that mean? So let's talk about inclusionary. That usually makes things a little bit more understandable. Inclusionary includes this less than or equal to and greater than or equal to. So let's start with these first. If we say, is 2 greater than or equal to 2, this is true. Because 2 is included. That's why these are inclusive. And these are exclusive. Because if we say is 2 greater than 2, then no. Because 2 is not included in the variable, in the comparison, in the comparison. Think about when you are wanting to ask someone, hey, do you have 3 apples or more? Well, if you have 3 apples or more, that is greater than or equals to. If you ask someone, hey, do you have more than 3 apples? If you had 3 apples, your answer would be no, I don't have more than 3 apples, because it's not inclusive. So let's get rid of some of this so I have some more room. All right. Let's talk about some of the other ones. Equals to. Now in math, we use one equal sign. Don't know how I did that. That's fun. In math, we talk about one equal sign. However, in Java, one equal sign is known as an assignment operator. So we can assign something to a variable. Similar to what we did up here. We took the answer of this and assigned it to B. If we want to check the comparison of something being equal, we must use two equal signs. And don't worry, you're going to make this as a mistake. It's a common mistake that we all made when we're new to Java. And you're going to get a weird error about it. And the error probably won't really tell you exactly what's going on. But as you're looking through your code, remember, when you start using your if-else statements, you're going to want to use the two equal signs. Not equal to is an exclamation point, then equal sign, also known as a bang equal. Bang equal. So, is 2 not equal to 3? That would be true. In our examples over here, we're saying that the radius is 5. So is radius less than 5? No, it's not. Is radius less than or equal to 0? It's also false. You can go through the rest of these and look at them. The examples aren't all that good because we know that radius is 5. If they had put some of these numbers more like 5 also to do that near compare, then we'd understand them. But obviously, radius is greater than or equal to 5. So that's why it's true. As we know, if you're able to download this presentation and the examples work for you, give that a shot. It's great to do that, and it'll give you a little more understanding. Now let's talk a little bit about one-way if statements. In a one-way if statement, our code is going to check on something. If the code is true, it's going to run some code. Otherwise, it's just going to exit out the program. So for example, in this, we remember radius is 5. Is radius greater than or equal to 0? Well, yes, it is. So we're going to run this code. Now, typically, one-way if statements they're used to check input. And this is a good example. So in this code, up here somewhere, more than likely we got the input for radius. Maybe we asked the user what the radius is, or maybe we read it from a file. Not real sure. But we know that radius was picked up from somewhere. Well, what if someone somehow entered in -1? But we can't do this math. This math won't make sense doing it on -1. So that's why we're checking to make sure that the radius is greater than or equal to 0. And in this case, if it's not, then we're not going to do anything. We're just going to exit out of the code. But if it is, then we're going to run this math on it, and we're going to tell the person the area of the circle of the radius is this. By the way, just side note, in this example, there's a little bit of an error here, because if the radius was 0, we would not do this code. A circle with a radius of 0 is not a circle at all. You don't have a circle if the radius is 0. So you have to have some radius. So this is a good example of inclusive versus exclusive. While they are using an inclusive comparison, they shouldn't be. They actually should be saying radius is greater than 0. Just some food for thought. Now let's take a little bit of a moment to talk about our notation when we're programming. In this side, we can see that our code is wrong, and the reason why it's wrong is we're missing these parentheses. So we need to get these parentheses in there. That's how we tell our code what is part of the comparison. And this will definitely make more sense when we get to some compounding of our comparisons. When we have more than one comparison in an if statement, we'll see where these parentheses really start to play some value. This next set of code is to explain that if you have what they call one-lined ifs, where there's only going to be one line of code that's going to execute based on that if statement, you don't have to put these curly brackets. Now, again, this typically turns out to be a preference within whatever organization you're working for. Here in this class, if you have a one-lined if, you don't have to put the curly brackets. But a lot of organizations have the coding standard that says, we don't care if it's one-lined or not, make sure you put curly brackets. It makes the code easier to read. A little side note to this, if you have more than one line of code that needs to execute, so we have a line of code here, maybe that's doing some math, and then we're doing a system out. As soon as you have more than one line of code, and we can count this as 1 and 2, you have to have the curly brackets. The two-way if statement. So a two-way if statements, essentially what we're saying is we're going to do an if-else statement. And this is known as an if-else statement. If something is true, then execute this first set of code. Else, execute this set of code. So here we can see the true and the false. And that's the way our code executes. Now, just a little bit of a side note. Even though we've talked about one-way if statements, these rarely actually happen. And the reason being, like in this example, we're checking to make sure that the radius is greater than 0 so we can do some code. And if it's not, we don't want to do our math. But more than likely, we would want to tell the user something. Like, we wouldn't just want to say, hey, if the radius is greater than 0, do some code. Otherwise, just stop. Don't do anything, right? The user would be confused, wouldn't understand what's going on, and probably thinks your program is broken. So most one-way if statements turn quickly into two-way if statements. And here's a good example of that, is we're saying if the radius is greater than or equal to 0, do this code, because we know that we can, because there's some value that's worthwhile to do code to do actual math on in radius. Else, well, they somehow the user gave us a negative number. We want to tell them, hey, you gave us a negative input, so we're not going to do any math. Again, just to point out, this really should just be greater than 0, because 0 is not a circle. So this is an example of an if-else statement, also known as a two-way if statement. That's where we're going to stop this video. When we come back, we're going to talk about nesting if statements. And we're going to talk about the different ways to do it and how that works out. See you on the next video.